while we're setting up, so maybe we can, how is it best to maybe move the chairs in front of this? Otherwise, a bit awkward with the thing in the middle. Okay, because we have 4 panel members, one of them being virtual, who's Malini, who we just heard. And then we have all these other panel members as well. So before we start, let's first introduce, let each panel member introduce themselves, and then we go to the actual panel. So we've just heard from Malini, she was the previous speaker. So maybe let's go down the row here. So, wait.
Thank you, Bram. Hi, everyone. I'm Nagappan. I'm an associate professor at the University of Waterloo. And I look at how and where the limits of using these tools are when it comes to helping developers build applications.
Thank you, May. I'm Danny Dick. I just presented earlier in the afternoon session. So I'm a faculty at University of Colorado in Boulder, and I'm also on an extended sabbatical with JetBrains. I didn't mention about I'm a part of the JetBrains research. And a lot of the work that we are doing is in this area of refactoring and agentic solutions, assistant and agentic solutions. And I'm looking forward to hear what these people have to say about this topic.
Hello, everyone. My name is Keheliya Gallaba. I'm currently working as a researcher at Huawei Center for Software Excellence in Kingston, Canada. My background is also in software engineering. Prior to joining Huawei, I used to be a grad student conducting research in software engineering. And before that, I worked in some software companies, some in small scale, like 10, 20 people, startups, and also bigger companies that had like thousands of people. So I had some interesting experiences in these companies. So I guess that's why I'm here to talk about developer productivity, how generative applications are helping with software productivity. Another thing that I'm doing at work right now is we are trying to build a platform that people can use to build foundation model-based applications. So we have some insights from that experience as well, talking to product teams and also talking to other researchers about this space.
All right, thank you. Malini, do you want to add a couple of words about yourself as well? I think you're still muted, I think. Sir.
Hi, happy to be here chatting with you all on the subject of productivity.
Cool, thank you.
And I work at Intel and open source and the chair of the OPIA Technical Steering Committee.
All right, thanks for that. And as already mentioned, yes, so Malini, is it possible to mute the mic when, just to avoid the echo, sorry for that. Okay, so yeah, and as already mentioned, so this panel is really about the claims of increased productivity, tenfold productivity or even more by generative AI, specifically for software engineering. There were already some examples given, like Jack mentioned this report from Google that like 1/4 of the code generated in this last period was actually generated by AI. There was also, if you Google a bit, some other kind of studies done by Microsoft, Accenture, and some other companies. 26% more pull requests being accepted, more 43 or something percent more builds being run, more commits generated by week, and so on and so on. Apparently, especially for new people, like junior developers who really can benefit apparently from these technology more than like more senior, more mature developers. So there seems to be a lot of kind of positive things being said. Of course, these were studies maybe a year ago. All these things change a lot. So I'm very curious to know, as a first kind of step in this panel, from the panel members, what are their kind of experiences in terms of maybe current gains shown by generative AI for software engineering, or maybe short to medium term gains based on your respective experience. And after that, I would like then to open the floor afterwards to the whole room here to ask questions you might have about productivity and so on. You can really, pick the brains of these experts here in the panel, to answer those things and learn more, figuratively speaking, about that. All right, so maybe let's start here. So maybe Oh, let's start there. Okay, cool. So, Keheliya, what's your view?
Sure. Okay, can you all hear me? Okay, so as I said, I have some insights recently about building foundation model applications, and we are working with foundation models also for our day-to-day development. Also, probably all of you have also used foundation models in some context these days. That's why we are all here, like using Copilot and stuff. And then there's these publications defining software productivity impact of the foundation models. So for me, I think there are two aspects. One is personally how these technologies are impacting us to deliver code faster or fix bugs faster. I think most of us have felt that impact. And then there are bigger organizational pushes about, can we increase the productivity of the whole organization, or can we deliver features faster? But at the same time, about software development productivity, there's also some arguments, so there are some discussions about how to measure software developers' productivity, what are the metrics. There's no one metric. There's some approaches like the DORA metrics, and then there's the SPACE framework that's proposed by Microsoft about developer productivity. But then sometimes if we look at the papers, they may be looking at like one metric, like the number of pull requests being closed, or number of builds triggered, or number of commits done. That may be not be a good metric. You may need a mixture of metrics to measure that. And I think in the SPACE framework, they mentioned about like developer happiness, developer satisfaction also as one aspect. I don't know how we can take into account these type of stuff when we are dealing with foundation model based users.
Thank you for that. So, Danny, what's your view?
So you hear all these numbers that people are putting 57%, 20%. So I think that's one aspect of productivity. Are we there at 10x? I don't think we are at 10x. Can we go at 10x? I think we will surpass 10x. But there's another aspect of productivity which I think Ahmed brought into when he showed how many professional software engineers are today in the world. I forgot what's the number, 28 million, right? And how can we get 1 billion end user programmers? Right? So if you're looking from 28 million to 1 billion, right now you're talking about 2 orders of magnitude, so 100x. And so that's a productivity not by just increasing the productivity of the software engineers, but by bringing a lot more people into the field of computing enthusiasts and supporting them. And I think one of the missions of AIWare conference, and that's what really attracted me, it's software developed by all for all. That's the future of software for humanity, something like that, along those lines. So I think that's another aspect of productivity. Like if we can open the field of computing so that more novices and computing enthusiasts can write some small programs that helps their particular needs, control their environment, better learn about their body, about what makes them productive as humans, right? So it's a lot of custom self-monitoring for health reasons, for performance, for happiness, for a lot of other reasons, right? So if we can enable these end-user programmers to step into the field of programming, and I think Ahmed said it's in the end is not about, right, the code is not the end, it's just the means to an end. The end goal is for them to create the best version of themselves. So that's what I'm even more excited about. How can we 10x? I think we are working to 10x a programmer, but at the same time, I'm a lot more excited about how can we enlarge the field and broaden the field so computing enthusiasts can get into the field and lower the entry barrier for them.
So with the kind of the 10x developer, one of the things that I was talking to someone from a company, and I was talking to them about, oh, these tools can improve your productivity by so much. And one of the things that they kind of presented is, if this is going to improve my productivity by, say, 50% today, but impact my productivity by 50% 2 weeks from now, that's a net neutral. You've not improved anything, and I've just paid a lot of money to a company to do nothing, right? So quality of these things, and a lot of, there's a lot of PhD students here, so there's a lot of interesting topics here, is that we've always looked at how to debug code that someone wrote, right? 2 years down the line, when someone is debugging code and now 10x the amount of code potentially, how easy or difficult is it going to be to debug that, right? Like, these tools are generating code at a huge volume, right? And 10x means 10 times more code, 10 times more things to debug. The human will always be the kind of the narrowest part of the pipeline here, the bottleneck here, that's going to stop a lot of things, right? So wherever humans are going to be involved. I was talking to a student who was saying this, right? How many of you here like reading code, right? Everybody likes writing code. We've just talked about these tools now writing code and humans reading code. We haven't been trained for it. How many courses in school teach us how to read code? But now humans are code reviewers. I mean, you're not going to suddenly, like Friday night, you're writing code, and then they install all of these tools, and then Monday morning, now you have to start reading code. That's a whole new process, whole new way of thinking that we are asking humans to start doing immediately. So there's going to be a lot of productivity losses as well. So these studies need to measure productivity not just in terms of pull requests and things, but in a long time frame, like 2 years, 3 years, 5 years from now, how is this impacting us?
Yep. Very interesting view. So let's first move to Malini, and then we can react to that. Yeah, Malini, your turn.
So I like two of the comments, and then I'm going to challenge one of them from Nagappan. The way I look at AI is it's going to help people just contribute new applications, make new things possible by lowering these barriers. Everybody doesn't have to learn to write code, write good documentation, or even write great English or Spanish or whatever, because we can use these translation services, these good prompts, and make things happen. Like, if I'm a doctor, I don't really have to know how to write C code or real-time code or whatever, and that's what I think is great productivity, great strides for the human mankind type of thing. But then to Nagappan's comment, like, hey, there's going to be so much more code, who's going to review it? And yeah, that was the beginning of machine learning, where it was all supervised learning. You gave it positive examples, negative examples, and so on and so forth, and you built your models. But today, with the volume of data we've been looking at and building these large language models, we're using a whole slew of large language models to be the LLM judges kind of thing. So we're going to just train a system to start reviewing code too. And what do I look like? Once upon a time, I was really a coder. Just code, and fingers would be tired, eyes would be tired, and long nights. But today, my role is more as a code reviewer. What are the things I look for? Are the solutions more general? Are they making any assumptions? Are they hard coding things as opposed to introducing constants, so I can just send in a new parameter into a script, or use a different language model? So don't, hard code the language model you're using inside your code type of stuff. So that's how it's going to be. We're going to write better reviewers for code that'll automate a lot of it, and then maybe it'll be like, summarize this code, has it met some basic considerations, and then we'll take the next step of the human looking for some more corner cases type of stuff. So net, I do think it's going to help us by new innovations, by letting people who have subject matter expertise deliver products and solutions. And I think that's so compelling. Like, Once upon a time, it was so hard to maybe create a web service, multi-threaded, the sockets just listening. But today, everybody just uses a library, and there you have a web service, with Nginx or whichever way you want it. Even in my Python, I say create a web service. So I think that's what's going to happen. We're having more libraries to make these sort of things happen.
So it's like shifting responsibilities, basically, from what the human has to do. It just shifts to something else instead of like just being a roadblock or being a bottleneck. Right. So I think there was Danny and then Keheliya.
Yeah. So I want to piggyback on this idea that started by May and continued by Malini. So if you are looking at what's the lion's share of today Gen AI, it's everyone talks about generating code, right? So it talks about kind of like this Copilot, which kind of like became like sort of a brand, it's you're co-piloting code, right? But I think I fully agree with them, and if you talk with Michael Godfrey, who is one of the pillars in the software maintenance community, he will tell you that most of the code development is not about writing code, but I think what they say, like 80-90% of the software development costs are software maintenance, and it doesn't involve writing and spitting new code, but it's actually understanding and changing and improving existing code, right? So I think that's the big gap, and until we focus on the maintenance part, and until we shift the emphasis from using generative AI to write, to speed new code, to help us to process and to improve existing code and to digest existing code, like if we are generating 10 times X more code, right? So we need to have models to help us better in that. So I'm curious what Michael thinks about.
Yes.
Yes.
Hello. Yes, we've got this very idealized world we've been talking about now where everything is greenfield and you discuss it and then it magically appears and maybe you convince yourself that it's right. But yeah, there's going to be a long, long transition period of gaining trust for it, understanding where the weaknesses are and trying to deal with, mixed versions of the code. I've got this thing that somebody else developed, which they didn't use AI for, and I have to understand that well enough in order to have the conversation to describe what I want, for example. So yeah, I think there is an awful lot of work that's going to need to be done, as well as all this lovely work on the greenfield stuff that we're talking about now.
While we have in a subtle manner opened the discussion to the group, Keheliya, you also had a comment?
Yeah, I also had to add a comment to the discussion. So I think we are talking about like two different worlds actually. Like one is that everything is generated by all these language models. So people explain things in natural language. You get an application for one requirement, or you build all the software or applications from scratch using language models or some foundational models. That's what we are envisioning and we are building tools for. There are different set of challenges for this type of stuff, like do we need different cognitive architectures, different agents, or different better models, things like that. And then there's the other problem of there's already a lot of code out there, so how can we integrate with them, and how can we treat these models as like a co-pilot or an assistant who are living with us, who is a team member that is adding features, fixing bugs, working with us. So there's like whole different challenges at that part, like maintenance stuff. I think we have to have an idea about that. About that part, the maintenance part. So I have an interesting story about that. I was listening to a software consultant who had like a lot of experience coaching software teams about software maintenance, technical debt, this type of things. So what he said was he's usually asking the team members when he's like consulting on a code base, he's asking the team members, how confident are you about adding a feature to this code base and that will work as expected? And how about adding a feature and it will not break the existing features? How confident are you about that? And how confident are you about this software working as expected? So these are the questions that they're asking. So if the engineers, the team members are not confident about these things, that means they have a lot of technical debt, or they have some process problems that they have to deal with. But all of these things, we are currently working with other humans using these automated tools as support. But in a future where all these large portions of code is generated by these foundation models, how can humans be confident about these things? Like, as a human, when I'm co-working with these foundation models, when I'm adding a feature, when I'm fixing a bug, if I haven't seen the code generated by the machine learning models, or if there's a lot of code that I don't know what they are doing, how confident I will be about this code base, like what type of issues it'll introduce. So I think the problem there is, so at the short term, as May said, we will be introducing productivity gains. Like we will measure over a short period of time the productivity gains, but over the long term, the effects for the code base that we are not monitoring, or we don't putting effort right now studying.
So just to kind of clarify, right? Like, I'm not saying that these things, like, we shouldn't work on code review tools. We should be working on all of those things. They're not there yet. The current code review tools, about a month ago, one of my colleagues, PhD students, just defended his PhD on code reviews and found out that most of these tools give very vague, generic comments as code reviews that mean nothing. That mean absolutely nothing. They just say, it's not wrong, but they mean nothing, right? So it's not useful, right? So we still have a lot to do with these tools and build, and we should be doing that. But my concern with some of this is that if we measure productivity and start adopting based on short-term metrics, we might burn ourselves in the long term. And that some of these things should be measured with a long-term view, right? Maybe we won't have software, like 5 years, 10 years ago, there was this whole principle that software lives for about 25 years and then there's a slow death of that piece of software. Maybe we won't live 25 years, but even 5 years for a piece of software to stay, we need to kind of look at that. And I think the productivity gains, the big productivity gains, are going to be like what Danny and Ahmed were saying, is that we're not making each individual developer 10 times more productive. We're going to get 100 times more people programming on this.
But in the meantime, you also got somebody in the audience, Jack, with a question.
Yeah, so maybe let me start with an analogy, because when we talk about developer, there's another type of developer, which is building developer, right? Or construction people. The reason I draw that analogy is because it's in Toronto, as you can see, there's a lot of construction going on. And sometimes you kind of drove past by every day and suddenly you realize, wow, the things get built up so fast. And I just noticed, because before I didn't know, I saw it was just like the old comic book, like you build it brick by brick. It's not really what's happening these days. Instead, they have these kind of concrete template. They kind of stack on top of each other instead of kind of doing it the very small, granular, kind of brick by brick. And if we kind of think about this in this way, like when they originally built the building, brick by brick, even by machines, it doesn't speed up that much, because you have to, for each layer, you have to wait for the concrete to dry out and then build the next layer and so on, right? But suddenly, if you have that already readily available kind of concrete blocks, then things get kind of speed up quite fast. So I think right now, if we're looking at this LLM-based kind of code generation and so on, it's very cheap and very fast to generate kind of line by line kind of things. But do you guys think it's actually working at the wrong abstraction level if we are truly aiming for this kind of 10x, even 100x kind of developer activity? Because what I think Malini actually mentioned kind of is also related to this, but I don't think library is at the level of abstraction yet. But if we can find the right level of abstraction in the sense, there's definitely no need to generate new code for every single thing, right? If we can find the right kind of concrete blocks every time we just stack on top of each other, maybe there's a chance like we can reach much bigger developer productivity boost. I'm just curious, what are the panel's view on this particular case?
Right, so Malini.
I'd love to add there. So just going back to my 30 plus career in software development, the early days of compilers and bugs was they would just draw a little picture. There is a bug somewhere. And, I wouldn't know where it is. I have to really dig through. So we've made such rapid progress in compilers, debugger tools. And in this incarnation of software generation, we've reached this notion called a microservice. It's a single modular unit that people can develop, our audience members said, like prefab walls, windows, buildings, heaters, exchanges. So you start building those buildings sooner. And that's what the power of microservices are giving us today. You can just combine them. In my previous picture, the guardrail was a microservice. The LLM was a microservice. The data processing was a microservice. So I think libraries, when we were talking software, when we were building it, but now we're thinking at the level of microservices, and those microservices can be in whichever language of your choice. They still can talk to each other, whether it's through gRPC or HTTP or HTTPS, or even maybe tomorrow with shared memory if the microservices were on the same physical node that had shared memory. So that's the abstraction we'll have to reach for to make us much faster. And that's happening today with these microservices.
I want to comment on that. Okay, now it should be on. I want to comment on the example that Jay gave with the bricks versus these building blocks, right? So if you're looking in the evolution of programming, right, when the equivalent going between bricks to bigger blocks to bigger building blocks and bigger, right? It's the equivalent of going from assembly to structure programming to imperative programming, object-oriented programming, and then to libraries, right? So when you're looking right now at prompts, someone said prompts must die, right? I think that was the end of Ahmed. I'm quoting Ahmed, the wise man, the sage, the wise sage. As a wise sage who sits here said, prompts must die. That's the equivalent of, it's even below the bricks with the prompts. It's even below the bricks, right? So what's the equivalent of this higher level compositional library services or microservices that Malini said, that an end user will say, take this module, and if you're thinking about, people were envisioning this visual programming where you get these building blocks and it's a library of these building blocks, and you assemble, you draw and put together, a unit that can read input-output files. You have another unit, so you drag all of these things together, right? So that was visual. That was the idea of this visual programming. You have this higher level interface that you drag all these components together and somehow you assemble them. We don't have that yet. I don't know if visual programming is coming back, or maybe it will be the language that end users use to build those kind of building blocks will have to elevate at that higher level of abstraction. And then we also have to teach them more computational thinking, right? Because then they have to be a little bit educated about, they have to have the mindset of not a computer scientist, but a computational thinking, right? So that's what will distinguish between the illiterates and the literates in the next century, right? It's those people who have this computational mindset or computational thinking that can express things that these foundational models could make these bigger, larger building blocks. So that's, again, I don't know exactly how those will look like and what's the vocabulary and what's the language for that, but I think that's the future where average people, we can educate them, we can teach them these computational thinking skills so we raise their level of language and their level of vocabulary to that level, so they can not put like a brick with a brick, but they can put these bigger building blocks together. That's my view on this.
I'd like to add a few comments to that. These visual languages are coming. There's the evolution of no-code, low-code kind of user interfaces, and we're also integrating one of those with Opia. So you can say this block can connect with that block and that block, but does it make sense? Is it a meaningful chain at the end of it? That's another question. But people can drag and drop things, and part of those Gen AI pipeline examples that we have is so that people can just upload that into that no-code, low-code UI and then flip the blocks and say, I want a larger vector database or one that's more responsive to scale. But the way I'm seeing these early days of, even though I call it the high noon of AI, is there's going to be the smart people to help still saying, hey, this building is tornado proof, or it's waterproof, or it's heat efficient. So we will still need some good features to describe these things, and it's evolving.
So with the low code, no code kind of thing, there's a non-computer science, non-technical aspect to this, right? There is the no code, low code era that came up when mobile apps came out, right? There's a lot of these no code, low code things that came in. There were boot camps all around that said that we'll teach you how to use these no code, low code things. But the non-technical, non-computer science problem with this is that are we building software that, am I building a software that I will use, or am I building a software that many other people will use, right? Now, low-code, no-code software is a great way for me to build personal software. It is not, it has not been proven to be useful for application. Like no application that has more than 1,000 downloads, no mobile app that has more than 1,000 downloads was developed with no-code, low-code platform, right? Because whatever you can develop with that, anybody else can develop, so they don't want to get your application, right? And I say this because we tried doing this with people who didn't know computer science and kind of trained them into this, but it was a failed project because none of them could monetize it. They couldn't get jobs out of it, right? If we build software to sell to others, that's a profession, right? Like we all took computer science here because it was going to be a profession, not to write software that will help me wake up at 7 a.m., right? 7 p.m. too. But so that's a non-technical challenge that exists with how successful no-code, low-code will be, right? Like who are we building this software for, and where is it going to go?
I have two comments. I'll start with the thing that May just finished. So, but my thinking is, should we stop building low-code, no-code platforms because of that? Because we cannot sell them. Because I saw this nice example. I know some of you have already done this, like with these new tools that are coming up, that you can do some natural language queries with a model, and it builds you a app on the side using web technologies like Cloud Artifacts or some. There's an open AI tool also. So it could be one-time use, but if it serves some purpose, and if it doesn't, you recreate and build a new app and get the thing done. For example, I was listening to one professor explaining how he built this small app that he wanted to teach his daughter how to read clocks. So he tried drawing that on a paper, but it was too tiring. So he prompt Claude to build a clock generator. So it was for teaching his daughter about reading clocks. But there are like millions of users like that. People have some niche thing that they want to build. They may not have like thousands or millions of users, but it's useful and it's making people productive. maybe we don't know the monetizing model yet, but there could be applications of that. That's one thing. Like, I just want to share that story about how people becoming productive. And the other story was about the building blocks for humans. Like, what is the next level abstraction for humans to put these things together? My comment will be like, won't anybody think about the models? So what about the abstractions for the models also? So right now, all these guidelines we have about like writing comments, the method size, class design patterns, all these things are catered towards other humans reading that code and extending on that. So it's limiting on people's memory, like how much information they can keep in their brains, or what is their short-term memory, what's their long, like context size. But if we are writing software to be read by language models, what are these abstractions looking like? Like, what is the abstraction that is suitable for a language model? So I read this nice paper called SWA agent. The whole idea there is how is the editing interface or searching interface? All these interface should look like if these interfaces are used by foundational models. Like, what is the correct abstraction for them to do a better job? It may not be readable for humans. It may not be like maintainable for humans, but it may be the most efficient way to communicate our things to the models. So that's the comment.
I have one child who is in the elementary school, and the teachers are saying, well, one of them says, funny, you need to know your 3 R's. What's the 3 R's? Reading, writing, and arithmetic. Right? The 3 R's, right? So now I think the 4th R will be some sort of computational thinking, right? So when we start to teach at elementary, when kids go to 1st grade, kindergarten and 1st grade, and the way how they learn how to read and how to write English or their native language, that's also, they learn how to speak with computers and to, right? So we know how to communicate with people, but we teach a skill of how to think and communicate with computers. I think that's when we can start thinking about where are we raising this level of abstractions and how can end users, and you're right, do we need, like, if we have like 1 billion people writing this no code, low code, like, who is going to buy that? Like, the other 8 billion, the other rest of us, like, they're like 1 to 8. Like, you cannot, right? So that I don't believe that people are going to write that kind of software to sell to other people. And then, then why are these computer scientists? Why are these studying, software engineering when 1 billion of people are going to create software, right? So the issue is, in my mind, the people who are going to create software that is reusable and used by other and consumed by other at large scale, they will still have to go through a professional software engineering training. But the people who are going to use low code, no code is the kind of stuff that you say, well, I want to quickly program an alarm to wake me up at 7 p.m., I want to, and it's a smarter alarm, right? So they can probably connect with the lights or something, right? Can do something better than just, setting up an alarm clock, right? Or, I want to do something that will monitor my glucose level and, monitor my activity or something, or foods or something, and can figure out, give me some sort of, I can monitor how my overall health being and stuff like that. So it's stuff that it's private, that it's personal, that it's kind of like I'm the only consumer, and maybe my children or maybe someone else, my family, I might be showing that off to them. But I think there's always be a need for people who build these huge, massive software infrastructures, and those will not be done with low code, no code. They will be done by people like you who have an advanced degree in software engineering and computer science and get master's and PhD level of education in that field. So I don't feel that any of you will have to worry about, oh, what am I going to do? Because 1 billion people are going to write software, so who is going to buy my software? So people are going to buy your software. They're not going to buy the software that is written by a low code or no code. Like, those are more like personal consumption. That's how I view it.
Yeah, That's what I'm saying.
Very,
Yeah.
very well said. Yeah. And even the early no code, low codes for user interface design, I mean, they were like, there was something like hot metal something just to create user interfaces, put a button here, change the background, put my logo, and that was good to explain to high level execs what this user interface might look like, what the flow might be, but then we needed the regular computer science people behind to code it up. But that was a great show and tell kind of thing. And
Yeah.
definitely I loved your glucose monitor example, like can I eat that piece of cake today because I was good or I walked enough, and yeah.
I completely agree, right? Like there should be, and one of the reasons I think is also that the low code, no code platforms don't have all the bells and whistles that come with an IDE, right? No one's doing static analysis, no one's doing testing, no one's doing release engineering, no one is, and you don't need for their personal applications, right? So when you want to have others use, you still need. So my whole thing is that there is going to be a dichotomy. There's going to be a need for a 10x or supporting developers building applications, and there's going to be a need for building things for the remaining 1 billion too.
Cool. So let's switch gears.
Could you hear me? So let me set up a bit of context, and then I will present my question. I have been contributing to the implementation of a variant of Python that we compiled to the Tezos blockchain platform. And we are using a couple of languages, OCaml, Haskell, and so on. And regarding Haskell, we use some advanced features of the type system, of the Haskell type system. And I needed to integrate a specific genetic library in the code. And for a really corner cases, I found a compatibility issue between the advanced type features and the library. And surprisingly, after asking a foundation model and spent some kind of 2 hours to find a solution, I identify a possible solution to that problem. And it was really good. I believe that it saved me 2 weeks of learning some advanced Haskell systems. But on the other side, I missed a nice opportunity to learn. So it seems to me that, of course, the foundation models may save time, but also may somehow compromise the learning opportunity of software developers. And I would like to hear your opinion about that, if possible.
So exactly, right? There's going to be a lot of great use cases of using this, right? What you're describing is similar to, I think it's called the ducky model or something like that. There are developers who have like a little small plastic or rubber duck sitting on their desk, and they try explaining things to that, and they suddenly figure out what mistakes they made, and they're able to fix it. It's a very intelligent duck, right? You can talk with this, and you can learn. There's going to be refactoring. See, there's a lot of very nice use cases. So I think for PhD students and product developers, I think we need to find out where it's really going to help developers and not use this as a blind hammer and just say, I'm going to take a task and I'm going to throw an LLM at this and I'm going to see if this improves, right? Let's see where the opportunities are. And there are a lot of such opportunities where this is going to help. And there are some opportunities which I think is really not going to work, or worse, it could actually make things a lot worse too. So I think there's still some research on that, right? A recent archive paper that came out, which basically said test generation for using LLMs is very dangerous, right? Like there's a lot of research, there's a lot of products now, there's $1 billion company behind one of these products, very dangerous, that they will actually validate errors, right? So there's a lot of problems in some areas, more harmful than even just neutral. And there's great places like what you said, having discussions, refactoring in places where it's going to be really helpful.
The views.
If you remember my story with going up the canyon and riding an e-bike, right? So some people, like myself, so I couldn't go up and go thousands of feet or meters elevation gain without that. Like my body doesn't allow that, doesn't have the capacity. Now, talk with my student Bram, he does that all the time, but you know, I cannot do that, right? But when you talk with people who've been riding an e-bike, and people especially who are coming from a professional athlete background, they're saying, well, they enjoy that part, but then they also miss this sort of like grit, that kind of, that going up on a steep mountain, on a mountain bike trail, and almost like like when I talk to them and when I read, they're even almost equating that with, I have like a spiritual experience, sort of, you know, like my soul, my mind gets freed of all this clutter, and when I kind of like push hard and go. For me, I never had that. For me, I cursed, and I never enjoyed that. You know, I always enjoyed the downhill, going the downhill, right? You know, but going uphill, no, I never enjoyed that, right? But so that's the equivalent of what you said. You know, well, I can take this shortcut and do something that is going to take me 2 weeks, but give me that kind of sense that I'm the master, I'm in control of everything. Versus, you know, I take a boost, right? Like how I get from my bike, I can get up to 400% assistant of, you know, it's not a motorcycle, it's how much I push, it responds back with up to 400% of the gain that I put into the pedals, right? If I put 0, it gives me 0 back, right? So it's always, you know, that's one in my mind, that's a great analogy, because it depends on why am I doing it? Am I doing it to be a master of that technology? In this case, you know, these are professional athletes who, you know, they get a deep sense of inner peace, and their brain clears up of all the fog when they go through this huge, massive effort of going up the mountain, right? Or am I doing it not to go uphill, but to go downhill, which is, for me, the only purpose to go uphill is to come downhill, right? So I think it depends on what do you want to get out of it, and that's how I can see it as a physical metaphor of what kind of person are you? A recreational, avid bicyclist who enjoy being in nature, or do you go in nature so because you can do a sport and you can train your body and you can clear up your mind and clear up the fog up here in your brain? So what kind of person you are and what's your ultimate goal? That's how I view it. Who wants to?
I just want to add to Danny's comment. I mean, just because we have cars doesn't mean we've stopped running or walking. We need it for the exercise. And your question, there's a philosophical ramification too at like the school level, at the college level. Should kids use AI to do their homework? And some of the teachers says, yes, let them, you know, learn how to use AI so they can be productive, faster, whatever, when they need it. But we also want them to develop their critical skills, their own writing abilities, and maybe use AI to help grade them. So exactly, you have both needs. And one time I did try to do a shortcut and said, you know, what is this project Key Cloak about? And then I read the answer. It had hallucinated extensively, and I said, oh, it's all world hunger, great. And it wasn't any of that. So at least in these early days, you can't trust everything the AI gives you either.
So I have multiple comments because this is a very interesting discussion. So I have multiple things to say about this if we have time. So the first question, so the way I'm glad that your problem got solved, you got it integrated, but I thought the conversation was going because there's some papers being written about like there are a lot of examples out there on the internet about how to use Python, how to use JavaScript, TypeScript, and these type of languages. There's a lot of open source code written in those languages on GitHub, but there could be like some other languages that there are not many examples, so the language model may not have some good answers. They may just like repeating stuff, hallucinating stuff for languages like not very commonly used. Or there are programs out there, but they're not in the public, like for example, OCaml. Yeah, that's a comment about that. And of course about the test generation, I totally get what you said. Like there was an example, they said like the user said in CI, make CI pass. The bot just commented out all the tests, so the CI passes. so there are cases like that, like when we think about what we are telling the model to do and how it's listening to that and doing things. And then about what Malini said about like teaching people how these models work. I think this is a very important concept, because I think I've seen people talk about these problems. Like they say when we give this to a machine, or when we give this to AI, it will do a better job. They may not know about hallucinations or the shortcomings of these models. So they assume, oh, if this is taken care of by a language model, or if this is taken care of by artificial intelligence, this should be better. So by letting kids use these models and letting them prompt, we give them insights about like what are their limitations. They are not really like 100% perfect. They have these limitations. You need to give them examples. You need to rephrase things in a certain way. So these limitations, maybe the younger generations are getting true experience of this, and maybe people who are not very familiar, who didn't grow up with these technologies, may have some bias about these technologies, that they are perfect or they can do better job. That's my comments about that.
All right, so we have about 10 minutes left, and there were like 2 questions. So let's go there first.
All right.
Oh, sorry, 1, 2, 3. Okay, 10 minutes. Okay, sorry, you're number 3.
All right, thanks.
Right.
All right, so my question for the panel is, I should ask a question at the very beginning is, so what do you see the metrics to be used for measuring the productivity for the developer in the LLM? Because if you look at software development nowadays, we're still using how many issues we fix, how many features we implement, how many test cases we write to measure the productivity of developers. But if eventually if the FMware is achieved, developing software will be as simple as click the button, right? So how are we going to measure their productivity?
I'm going to answer that question with another comment or question, really. Like going back to biology, Charles Darwin and all would talk about mutations, right? I mean, suddenly the giraffes have longer necks. But did they figure out that they needed a longer neck and get to that point by like manipulating one gene or something, and then, be able to reach trees that were higher and leaves that were higher and all? No, it took a very long time. So if we just use AI and things like search, I mean, for me, AI it's just search, just very, very sophisticated search with good reward functions and so on and so forth. It might take a long time. So I think we're not yet there to say we're going to become super productive with AI. Even how we measure productivity will have to change and evolve. But just random mutations, like the way Darwin suggested happened, it's going to be a very, very slow evolution versus a more conscious, like, hey, I need to manipulate the gene, which is the gene that controls the neck length and blah, blah, blah type of stuff. So that's my take. It's still very much a search task today, machine learning.
So, Song, if you like one of the things that Ahmed kind of pointed out from, I forget the Google developer's name who presented in 2015 on the ML part, right? Scully. There's never going to be I click the button and the FM is ready, right? There's going to be a lot of other things than what we normally do now. There's going to be other ways in which it happens. And I think productivity will be defined, the metrics will be defined by the outcomes that different people have, right? For a CEO, productivity is, am I getting more for less, right? For a developer, the productivity will be, am I happier in building things? Am I going to be a long-term contributor? Shareholders might want productivity only for this quarter, right? But a private equity firm might want productivity over 5 years. So there's going to be a lot of different ways of measuring productivity. And I think the mistake that can happen is defining productivity one way. If you think productivity should be measured only in one way, that will be a mistake. I think productivity will have to be measured in a lot of different ways. But we need to know what the validity threats in each of those measures are before we take insights from it and see how we can use it. Right? What is the problem with that metric, and where should we use it or not use it?
Okay. So this 10x productivity. So I think Phenom asked earlier today, he said what it would be basically the IDE, not for humans, but what is the IDE for the agents, right? And I think the question right now today is how can we improve the productivity of these AI agents themselves? And very concretely, on Friday, there's a company called All Hands that released results now that's showing for SweetBench, they can go over 50%. Now, they don't say it, explicitly, but if you read through it, really what they have done is they've made their AI agent more productive. Today, if you develop these AI agents software, you realize that these agents are really not the most productive people ever, right? Sometimes the agents will chit-chat with other agents. Hey, what's up? What's the weather? Really, at that level, right? They get lost. They get confused. So I think today a lot of our tooling, what if we were to rethink JetBrains? So there'll be JetBrains Human Edition, JetBrains, the AI edition. What would that be? And even on our case, we have recently added a debugging skill for, capability for an agent. And we found that it actually did use it. And there was a lot of problems that I was kind of stumbling on it. I did this wrong. Okay, now I use that to fix myself. So my feeling, or I guess my challenge, at least I can say clearly, so before I used to say 10x is going to be very hard. I still think it's going to be hard if you think of human. But I do believe 10x for agents, coders, where it's easy, even 100x could be. So happy to hear your thoughts, maybe from other people's thoughts on that. And Gacy, what would be, if you're a student, and I want to know, what would be the first free project I should work on to make my new Asian buddies more productive? Any ideas on that?
I mean,
debugging, I would say.
Yeah, debugging.
Debugging probably be one of the first ones. Yeah.
We recently wrote a paper about code understanding, and for once I actually agreed with the negative review. There was a strong reject review, and I said, you know what, they're right. And the review said, you can't call this understanding because there's no evidence that these models actually understand anything, right? So they may be summarizing. So I think summarizing what the tasks are and trying to see what I should focus on, planning, trying to see how to do these things, right? I don't know if mimicking humans is going to be an optimal way of improving productivity, but I also think there's going to be a lot of students should have a stronger ML background, a much stronger ML background if they're going to improve the productivity of these agents. It is not going to be just like prompting and trying to figure out some software engineering way of doing this, but maybe there's a fundamental difference in the model that we build to make them more productive.
Ahmed, I wanna. Oh, Malini says something. Yeah. Okay, go ahead, Malini.
Okay, so I just wanted to comment on this question itself. Okay, what do you mean by productivity improvement of the agent? And let's just take, for example, an agent that should recommend some stock I buy. Okay, I can say, okay, let's buy AMD or let's buy NVIDIA with what I know. But that's something everybody might know. I mean, like, okay, AI is big and, those GPUs are important, blah, blah. But it's making a call before others know what to call on. I mean, to see that horizon even before your ship is anywhere near that, that horizon or the island or something. And it involves maybe searching a lot more data, seeing like the little needle in a haystack kind of thing and connecting those dots. So sometimes it's people you've talked to, sometimes it's articles you've read, sometimes it's seeing a wider span of research. So for me, just giving an answer is not the right answer. I mean, that's not your productivity, but how effective it was, or how much more profit you made from that suggestion or recommendation is critical. So I still hold that I don't know how to like quantify productivity. And like with all human endeavors, it might be your experience, it might be the amount of data you've consulted or the experts you've talked to, and so on and so forth for your agent.
I like that, Malini. And so what I'm hearing you say, it's how can I view more and how can I view before, right? And how can I view more, and I want more before, right? So that's one measure of productivity, instead of just being focused on I can generate 10 times more code. You know, how can I get more foresight? How can I get longer? You know, how can I get a longer term vantage point of what's happening right in our daily life? And there's another. I'm coming back not to the agents but to the human productivity. I wanna throw another idea of not only, you know, let's get out of this race of I'm writing 10x more code, or I'm writing 50% more code, because that can lead to human burnout. So if you look at our profession, what's the attrition, and especially if you look at different populations, so the highest attrition is women. So we already have a hard time bringing women into the field of computing. So here, you know, there are lots of women that we appreciate. This is really great. I've talked with lots of women who left the field of computing, and why they are leaving the field of computing. It's because they want to see what's the end, how is my programming helping solve some of the big problems in society, in humanity, in as a human race, right? And where do most of the women who leave computing go? Do you know what field do they go? Any guess? When women leave computing, where do they go? What field they go? Yes, medicine, yes. Why? Because that's a field where they feel like, you know, I'm going to a medical doctor, I get an injection, and, you know, within a few days, you know, the patient, or immediately, or within a few days, or short, like they're going to feel better. I have a sense that I'm helping someone, right? And I see that, so it's a short, right? So this is, I think, another notion. So there's a famous book by Simon Sinek, which is one of my favorite authors, called The Infinite Game. So it talks about how can we stay in a profession, in a career. How can we, instead of being how fast can I go to whatever goal or metric, how can I play an infinite game? So it's the idea of how can I stay in the game the longest. So if you're looking in our field, the amount of attrition and how people are burning out, there's a company whose name starts with A, which I should not say what's the name of the company, but it's famous. Most of the people who start working at the A company, they last for about 16 months, and then they change jobs because they are burned out, right? So what if we shift our notion of productivity? And I don't want to go to, I think you talked about drug dealers with happiness, and let's make people. But I think, you know, the analogy is, if people are happy, and if people have a sense of I'm contributing and I'm solving, and I'm seeing the end result, that the algorithms, the programs, the software that I'm helping building, it solves some of the humans' society problems and some of the long-term problems that we all care about deeply. Right, that's another notion of how can we help the programmers stay in this infinite game? How can they stay productive and happy and contribute to the society? So that's another notion that I want us to think about. You know, it's not just about writing lines of code, but how can we help people avoid burnout and avoid. So if with the help of AI, you know, I can do the same job, and instead of finishing it in 40 hours, I can do it in 27 hours, and 13 hours I get freed, so I can go and enjoy mountain biking and be happy. You know, maybe that's another metaphor of productivity. Maybe that's right. So, but the idea is, how can I stay in the game without burning out? How can I stay and play this infinite game without burning out? So that's what I want us to also think about programmer productivity.
That's a nice way to end the panel.
Reducing drudgery, yeah.
Yeah, so we really have to stop now because we run out of time, but I think it's a nice way to end the panel with this positive note. So thanks a lot to the 4 panel members.